FNC 311 Managerial Finance, Chapter 2 Time Value of the Money, Part 1. Agenda. In this short video, I'll discuss the following topics. Topic number 1, a timeline. Topic number 2, calculate future value for a given present value. Topic number 3, calculate present value for a given future value. Topic number 4, NPV, net present value definition, and the 3 ways to calculate NPV. A. Using the Excel PV function n times. B. Using the Excel NPV function once. C. Using the NPV true macro function. Topic number 1, a timeline. Okay, so this is after you type .c2, you will see the number 5. Okay, so .c2 5. And for many cases, we can draw a timeline to illustrate patterns of our cash flow. Okay, so actually, this is usually from the left to right. And if left is present value, right will be the future value. Okay, so we have 1, 2, 3, 4, 5, 6, 7 cases. Okay, for the first one is at time 2, we have a cash flow. C stands for cash flow. Okay, so usually, for example, we have $100 received at end of the second period. What is the equivalent present value? So we're given a future value, we calculate present value. So present value, we usually use times 0. Times 0 stands for today. So this is I called case number 1. So this is, we have one future value, we might calculate present value. Okay, so this is case number 2. We have one cash flow today. What is the future value 1 period later? Okay, I mentioned here same interval. So the interval can be year, so times 0, 1 year, 2 year, and it can be months or it can be day. So same interval. Okay, so this is pattern 3. So first cash flow at end of first period, and at end of second period, at the end of third period. Okay, later, so like chapter 3, I'll discuss this is called annuity. Sometimes cash flow can be continued forever. Okay, so this is at time 0, at 1, 2. So we receive cash flow at end of first period or at the end of each period forever. So this is called perpetuity. And we can add the time year, which year, like 2021, 2022, 2023. Okay, so we have 3 cash flow. For example, for these 2 cases, okay, we have 3 future cash flow. C at the end of 2023, 2024, 2025. And we calculate the present value at 2021. We can simplify as 0, 1, 2, 3, 4. Okay, we have 3 cash flow at the end of second, third, and fourth years. Okay, then we calculate the present value. It doesn't matter. This is 1970, 1971, 1972, 1973, 1974. Then we calculate present value of 1970 or 2021, or even this simplified notation. Okay, so let's look at a concrete example. Okay, assume we borrow $100 for 2 years. The annual interest rate is 10%, percentage rate. And then we can draw a timeline. So 0, 1, 2. Okay, At time 0, we have cash inflow $100. Okay. At the end of first period, we pay $10 as interest payment, annual interest payment. At the end of second year, we pay another $10 as the second period's interest payment plus principal. So this is this is timeline, and we can show our cash inflow, outflow clearly. Topic number 2. So let's derive future value for a given present value. Okay, so this is our objective. So our objective is future value equals present value times 1 plus R power is n. Okay, so we're trying to derive this formula. Okay, so this is our objective. Okay, so let's make a simple notation. Okay, suppose we have timeline. Okay, so this is time 0. So this is timeline. Okay, and so make it simple. Assume we deposit $100 in the bank. Okay, and of course, now interest rate cannot be so high. Okay, we deposit $100 in the bank for 1 year. Assume annual interest rate is 10%. Okay, why we use 10%? Because we can calculate easily. Okay, so this is how much? So this is time 0, and this is time 1. Okay, so obviously we are going to receive $10 interest payment plus 100 our principal. Okay, so this is our we will receive. Okay, so this is at the end of the year, and we are going to receive $110. Okay, so this is how much we are going to receive. Okay, so this is 100 times 10% plus 100. Okay, so actually if we collect term, 100 times 1 plus 10%. Okay, so this is our calculation. Okay, so we can, if we use present value, we can think about this present value times 1 plus R. Okay, and so if it's not $100, it's $200, then we replace this $200. If R is 5%, then we replace with 5%. Okay, so this is for 1 period. Okay, so let's look at the 2 period. Suppose at the end of first year, we continue to keep our money in the bank, and for another year. Okay, so this is we assume this is still 10%. So we are going to have 10% for 2 years. Okay, 10% for 2 years. Okay, then how much we receive at the end of second year. Okay, and we can apply this formula. You see, we applied the formula. Okay, so this is 110 times 10%, right? Plus 110. Okay, so this is because we know 110, so this is 110. Okay, so we just imagine if we are standing here, we withdraw and deposit 110 immediately. Okay, so 110 times 0.1, so this is interest payment. So actually is $11 plus 110. So finally is 121. Okay, So actually we know, so this one and 110 equals, so we just plug in this one. Okay, so this is 110 times 0.1 plus times 1 plus 0.1. Okay, we just apply this formula. Okay, so this is we apply this one twice. Okay, so this is 110. So this is, okay, so I'm going to make this one clear. Okay, so this is equals, okay, I'm going to delete this one. So this is 110 times 1 plus 0.1. Okay, so this is 110 times, so this is present value or new present value times 1 plus R. Because 110 itself, it is this one. So this is 110. So this number equals 100 times 1 plus R. Then we just times this one again. So this is times this one. So this is, then we can simplify the notation as 100 times 1 plus R power will be 2. Power will be 2. Okay. Okay. Apply the same logic. Apply the same logic for the 3-period model. 3-period. Again, the assumption is interest rate is constant. Okay, so this is so interest rate of third period, a third year, is still 10%. Then the future value at the end of third year will be this one. Okay, so this. So this is, okay, so this is 0.1. Okay, and if we generalize, then we'll have final for the same logic apply for the 4th period and 5th period until the nth period. Then we have the future value equals present value times 1 plus R raised power to n. Again, so this is the future value will be the future value, and PV is the present value. Okay, and R and N should have the same frequency. So this is, for example, if period is monthly, then the interest rate should be monthly. If the period is daily, then interest rate should be daily. And later I'm going to show you it should be effective period rate. Okay, so this is our final result. So future value of a given present value times 1 plus R raised power to n. We have derived the future value. So future value equals present value times 1 plus R. Okay. There are several ways to calculate future value. One is we just apply the formula. The second way is apply the Excel function. Okay. Okay, so let's try the formula. So this is suppose $100 and interest rate is 10% for 5 period. Okay, so this is present value, this is R, and this is N. Okay, so future value. So future value equals present value times 1 plus R, and the power is N. Okay, I'm going to show the formula. Okay, so we just simply apply the formula. Okay, so this is present value, this is R, and B7 is N. Suppose it's not 10%, it is 5%. Then we modify this interest rate, then it will get the final result directly. Okay, so this is in note 5. Suppose is 10. So this is the future value 10 period later. Okay, so this is a simple way to apply the future value formula for a given present value. Okay. From the previous topic, we know this is a future value equals present value 1 plus R, and the power is N. So let's call this is equation number 1. Okay. We can easily derive equation number 2. Okay, both hands, we know equation, right? Both sides divided by the same item. The equation will remain the same. Okay, so actually the future value divided by 1 plus R, the power is N. So equal, so this is right hand side. So this is right hand side divided by same item. Okay. Okay. So this future value. So this is future value divided by this factor on the left hand side equals, this is right hand side divided by same factor. Okay. So this and this can be cancelled out. Okay. So eventually we have future value. So this one disappear. Okay. Then we have present value equal future value divided by 1 plus R, power is N. Okay, so then we call this one equation number 2. Okay, so equation number 1 is we calculate the future value for a given present value. Okay, and for the equation number 2, it is opposite of equation number 1. We calculate the present value for a given future value. So this is why sometimes we call R as discounting factor. So usually we discount future value to calculate the present value. For this one, we compound present value to calculate future value. Okay. Before discuss two Excel related function, Excel present value function or formula, and Excel future value function or formula. Okay, and it's a good idea to discuss Excel sign convention. So what is the Excel sign convention? 7. Okay, a basic idea. Suppose we calculate we calculate the present value. If we enter positive future value, we got a negative present value. If we enter negative future value, we got a positive present value. The opposite is also true. Suppose we calculate future value. Okay, if we enter positive present value, we get a negative future value. If we enter negative present value, we get a positive future value. Okay, so there are two ways to explain or to remember Excel sign convention. The first method is accounting approach. Okay, so just remember cash inflow is positive, cash outflow is negative. For example, so this is example 1, and actually these two numbers are for these two examples, value are identical. Okay, we deposit $100 for 2 years because we deposit $100, so this cash outflow, so negative $100 today. Okay, and if the annual interest rate is 10%, how much the value in 2 years? Okay, because we have $100 cash outflow today, 2 years later we have 121 and cash inflow. Okay, so later I'm going to show you this formula. Okay, so let's look at other way around. If we borrow $100 today, because we borrow today cash inflow. Okay, so this is positive, we enter positive value, and because we lend, because we deposit cash outflow, it's outflow. If we borrow, so cash inflow. Because we borrow today, cash inflow today, then 2 years later we have pay back the cash outflow. So this is accounting approach. Okay, and the second way is much easier. Excel is simply designed this way. Next, so let's look at the two function, future value function, two Excel function, future value versus present value. Okay, so when we type, so let's look at here. Okay, so let's look at .c2. So this is the future value is 11. Okay, so this is the format. I'm going to, yeah. So let's type. So I'm going to explain here first, and then we go to Excel to look at in more detail. Okay, so if equal future value that parentheses, then we'll see the Excel will prompt all these 1, 2, 3, 4, 5 variables. Okay, input variable. Okay, the first thing is I want to explain the meaning of this squared bracket. The square bracket actually means these two are optional. Okay, so these two are optional. And suppose we have 3 input values, then it will treat as the first 3. Okay, for the one present value, when we calculate the future value of one present value, the payment always be 0, and this one should not be 0. So this is payment is 0, and present value should not be 0. Okay, so let's go back to Excel. Okay, suppose we have present value is 100. Okay, and interest rate is 10%, so 0.1. Now the period is 2. Okay, so what is the future value? Okay, so if we type future value, left parentheses, you will see this is a rate, this is now the period, payment is 0, and present value. Okay, the present value. And I'm going to explain type probably for the next chapter. Okay, so rate is 10%. Okay, so now the period is 2, and payment is 0. Okay, payment is 0, and this is present value. Okay, then close it. Okay, I'm going to show the formula. So this is formula text. Okay, so this is a negative. This is a red represent negative. Okay, we can change the format. So format, you see here, we use currency. Suppose we use number. We use number, and okay, let me see if we click OK. So this is okay. So this is number. So let's format. This is number use. So negative number. Okay. So negative number, we can use a negative sign in front of it, or we can use red one. Okay. Then we use parentheses. Then we use parentheses and red. Okay. Suppose we use negative signs. It's better. Okay. So if we deposit, suppose if we borrow $100, okay, suppose we use accounting approach, okay, if we borrow $100 today, so this is cash inflow, okay, so cash inflow, it is positive, okay, if annual interest rate is 10% for 2 years, at the end of second year, we have to pay $121. Okay, so this is we cash outflow. Okay, suppose if we enter negative 100, then we'll receive 121. So this is will be cash outflow first. Okay, cash outflow first, then cash inflow. Okay, okay. So let's calculate present value. Okay, so this is present value. Exact same things. Okay, the beauty of the Excel is we have 1, 2, 3, 4, 5 almost identical format. Okay, so we have rate and we have the period, and again payment is 0. Then we have future value. So future value 121. Then we get exact 100 negative value. Okay, I'm going to copy the formula. So this is the formula. Okay, so we have two functions. We have two Excel functions. Okay, the first one is future value. So if the future value, the first input is rate, the second input is number period, the third input is payment. For this chapter, and we only discussed one future cash flow, so this is a 0. And then for the future present value. Okay, for the second function is called the present value. The present value PV left parentheses. We have a rate, we have the number period, because for one future cash flow payment is 0, then this is future value. Okay. Okay, so these are two functions, future value versus present value functions. The last topic is definition and how to calculate NPV. Okay, so definition of NPV, net present value. Okay, so this is C212. Okay, and so there are two methods we can define NPV or net present value. Okay, the first is easy to understand. So NPV is simply the present value of all the benefit minus present value of all the cost. So this is easy to understand. Okay. The second method is if we define cash outflow is negative, cash inflow is positive, then we can simplify our notation NPV equals present value. summation of the present value of all the cash flow, including present cash flow and future cash flow. We are going to use one example to show you how to calculate NPV. Okay, so this is C213. Okay, so let's so this is I'm going to copy paste to Excel. Okay, 1 0 1 2 3 4 5 5 10. So this is should be 5 10. Okay, I'm going to separate them. So this is data and text to column. So this is space finish. Okay, so this is 5. Okay, I'm going to hate this. Okay, so this is okay, I'll make it bigger. Cash flow. Okay, so we have time period. Suppose we invest $100 today at time 0 today. We are going to receive $40, and at the end of first period, 30, 40, 20, 10. Okay, if discount rate is, so let's make it here. If discount rate is 10%, so what is NPV? So what is net present value? Okay, I'm going to use the 3 methods to calculate NPV. Okay, the first method, I'm going to use the deflation. Okay, the deflation NPV equals PV summation of all PV summation of present value of all the cash flows. Okay, so let's calculate present value cash flow. Okay, so let's calculate the first one. So we apply the formula, the present value, and so this is number of period. So this is a 0. Okay, sorry, rate. First one is rate. Because with fixed rate, we hit F4. So we use $D and $1. So this is 0. Remember, we are talking about one future cash flow. So this is a 0. Then this is negative 100. So we expect a positive 100. Okay, I'm going to show the formula. We simply apply the formula. Okay, the only difference between this one and the previous one is we log the discount rate or interest rate. Okay, and then we copy and paste. Okay, the total summation will be our NPV. Okay, so actually this should be positive. Okay, because we have opposite signs. Okay, so this is I call the method 1. So this is method 1. Okay, and so let's look at the method 2. So method 2, we apply NPV function. Okay, we apply NPV function. Okay, and however, NPV function actually is not it's not two NPV function. Actually, it's PV function, because we can only apply to future value. Okay, because this is 0 is present value, we can only apply to the future value. Okay, so this is rate. Then we apply all the future value. Then we add back initial investment. Okay, so this is the formula. Okay, I repeat the NPV function. Okay, so Excel NPV function only apply to future value. Actually, that is assume the first cash flow happened at the end of first period. So we cannot apply to the cash flow happened at time 0. Okay, then we have the plus back initial cash flow. So this is I called method 2. And you see we have opposite signs. Okay, so this should be negative, this one. So actually the positive sign is correct. Okay, so this is I call the method 2. So let's look at method 3. Method 3, we simply apply NPV function. We apply NPV function to all the values, including initial cash flow. Then we times 1 plus R. Okay, so this is the same thing. I'm going to format this one. Okay, so I'm going to show the formula. Okay, so actually for this one, it's okay, I'm going to remove the dollar signs. And for method 3, it's NPV. We apply to all the cash flow. We apply to all the cash flow, including initial cash flow and our investment. Then times 1 plus R. Okay, and we have the method 4. Method 4. So method 4 is simply using my Excel, using my macro. Okay, so let's go back to R. Okay, so let's see C2. And so this is a true NPV function. Okay, so this is 14. Okay, and simply copy and paste. That's it. Okay, so copy and paste. Copy. Go back to Excel. Okay, you click Developer and click Visual Basic. Click Insert. Click Module and paste. That's it. Okay, and if developer is not available, okay, I'm going to make it disappear, appear. Okay, so File, and when we copy and paste macro, we need a so-called developer. Assume developer is not on your menu bar. Okay, click File, click Options, click Customize ribbon. Then you will see the developer here. Okay, so this just click Developer and click OK. Then you will find developer here. So let's look at the NPV2. And so there are two functions. One is called NPV2 help, another called NPV2. Okay, so usually let's look at the second one. Okay, NPV2 help, you hit enter. Okay, so this is usage. NPV2 rate, comma, cash flow. Okay, so this is NPV2. Then we enter rate. Then we enter all the cash flow. we'll get the exact same result. Okay, so there are 4 ways to calculate NPV. Okay, and the first method, we apply the NPV deflation. We calculate individual cash flows present value. We have a summation. So be careful about sign convention. Be careful about sign convention. Okay, and so this is the most used method. Okay, we simply apply equals NPV function. However, we cannot include initial cash flow. We have to apply to future cash flow first, then we add back present value. Okay, so method 3, we apply to all the cash flow, including initial cash flow. However, our final result times 1 plus R. Okay, so 1 plus D1, D1 is R. The last method is simply apply the NPV macro I wrote. Okay, so that's it.